streaming going. All right, so there we go. Let me also get started on my sharing my screen. All right, can you all see my screen? All right, so there we go. Let me also okay, and let me minimize this. All right. How's everybody doing?
Good. How are you?
Oh, good. Great. Thank you. All right. Let's see. It's quite a few chats. I'm doing great. Thank you. Hope everybody had a great weekend. Ready for another week in database design. All right. Let's see. All right. Excellent. All right, everyone. Welcome everybody. We are starting the second week in our semester. Last week we we introduced the course, we introduced Canvas, we went through the syllabus to take a look at the various topics and how we were going to discuss throughout the semester. We also introduced you to Piazza as the main mechanism for communicating this semester, and to please post your questions on Piazza. Please abstain from sending me emails. It's Piazza will be a single place of communication. Also, we're going to have another 8 folks, 8 TAs that are ready to answer your questions. So definitely that's the better way of getting a hold of us, and that we're able to answer the same question for a whole bunch of people that might have exactly the same question. Also, we have links here for the 2 lectures available. If you prefer to watch this lecture a little earlier at 1:35 or the one that we're having now at 3:25, either one is fine. These lectures are being recorded both on Zoom as well as YouTube, right? So we are streaming all this live on YouTube, and I am adding these lectures also to a playlist you can watch there as well. And if you go to my YouTube channel, you can also register, and if you click on the bell, you'll be notified with every new video that comes up for this course. Also, we have the office hours that TAs have posted here. That we're trying to cover a broad swath of days and times that hopefully will match your particular time zone or wherever you are, and hopefully you can make use of these resources. Okay. Let's see. So last week we introduced the course. Also, we pointed out the links down on the left-hand side. The assignments are available here on the left-hand side, and they'll be made available as we progress through the semester. The first assignment is due today. We introduced it last week. It was about installing the database, setting up a development environment. We installed the MySQL server and the Workbench MySQL client, and we demonstrated that first assignment where we created a simple table. We insert a couple records, then we retrieve data from those records, and so we asked you to do this on your own and to share a couple of SQL files later tonight. Hopefully everybody's done with that. If you're still having some technical difficulties, TAs and myself, we can work with you to resolve them. We're going to be fairly lenient on this first assignment. If you still are having technical difficulties, we'll help you through that. But I believe everybody, most folks should be done and ready to submit later tonight. Are the other homeworks available, or we will only be available? So yeah, no, the whole course is programmed to go on autopilot, and yes, each module is locked until that particular week, and the assignments and the quizzes in there as well are locked until they are made available. Is it correct that the first 3 SQL files should be 1 or 2 lines of code? Yeah, it should be just a few lines of code. Yes, fairly simple. Obviously, they will be getting more and more complex as we progress in the semester. When is the first quiz? So the first quiz, I believe, is next week. Oh, actually, no. Yeah, so this is the second week. The third week is February 5th. So a word on the quizzes, right? So I've after having thought about this and noticing that folks are indeed in many different parts of the world, and to make it simpler for everyone, instead of forcing folks to be present at a particular time, what we're going to do is that we're going to make the quizzes available for 48 hours. So they'll be available, the first one will be available on February 5th in the morning, all throughout the evening at midnight, and then again the next day, right? So you'll have 48 hours to complete the quiz on your own. It is open book, and so you'll make sure to go over the slides from the previous week. Usually the quiz will be about the last assignment, okay, except the first assignment, right? The first assignment was just creating the database, installing it, getting it to work. There's no quiz about that, right? But like for instance, today we're going to be talking about the second assignment, the design databases designing assignment. So the quiz is going to be about designing, right? Database design, right? And that's going to be on the third week, right? So it'll be available, I believe, on Friday, and it will be available for the weekend, right? So it'll be available on Friday and then on Saturday again. Okay. So yeah, so review the assignment, review all the slides, make sure that you know where everything is, and then you can take the quiz on your own. It is timed. Usually it's about 30 minutes long, and you'll have about 5 to 6 questions. So I believe you have plenty of time to answer each one of those questions. The questions will be one at a time, so you'll get one question. You'll answer that question, and then you can go on to the next one. You can jump around in the questions, but you get one question at a time. Okay. Chat. Will there be time limit? Yes, the time limit is 30 minutes. You'll get 30 minutes to complete, and it's only one attempt. Yes, one attempt. Okay, let's see. Yeah, so quizzes. So quizzes are available here. If you click on quizzes, all the quizzes will be made available when they are for that particular week. And the names of the quizzes pretty much gives you a hint on what is the topic, right? So for instance, this week the topic is designing, and next week the quiz will be on designing. Okay, so it'll be whatever we just completed the previous week. Let's see something on the chat. What kind of questions? So most of the questions will be just either multiple choice or fill in the blanks, right? So we'll probably give you maybe like a snippet of code, and then we'll leave out some keywords, and then we'll ask you to fill in the blank for making the code work. Okay, so most of the questions are either fill in the blanks or multiple choice. All right, so let's see where we are. Let's go back to the modules again on the chat. Do we get our grade immediately? Yes, you get the grade immediately, but you don't get the answers to the quiz immediately. Okay, because again, in 48 hours, there might be other folks taking the quiz still. So we don't want to give out the answers right away, and they will be made available after everybody has had a chance to take the quiz. Then you can take a look at the answers, and if there's any issue that something was misspelled or something that you didn't understand or whatever, make sure to take a snapshot of this, of a screenshot of what might have been the issue on the quiz, and then send us a private message, Piazza, and then we'll make sure to take a look at what's going on, and we can retroactively regrade your quiz and see what we need to do there. Okay. All right. Let's see. Okay, so resources, office hours, and installing a database. Okay. All right. So late last week we had started on UML Class Diagram. We'll finish that up today. We'll finish that up today and then move on to data design. Okay. Now, we'll take a look at UML Class Diagram, and then we'll talk about the second assignment. We'll get you going with the second assignment, and then we'll move on to data design. So that's the plan for today. We'll work on these three things today, and then we'll finish off the other three topics next time we meet. All right. All right. Any questions before we get started? All right. Okie dokie. Let's move on. All right. So let's see where we left off last time. So last time we met, we started talking about UML class diagrams as a first step at working with databases, right? Implementing databases, designing databases. The first step is to come up with some diagram, some visual representation of what it is that we want to build. Okay, and UML class diagrams is a somewhat standard in the industry on how is it that folks, engineers talk about how data is structured. Okay, UML stands for Unified Modeling Language. Make sure you know your acronyms. Some of the questions here and there in databases will be asking about acronyms. So make sure that you know that UML stands for Unified Modeling Language. Although you'll have access to the data to the internet, so a quick Google search will be able to answer that. But make sure you know your acronyms. We did talk about how UML can be used to establish a language that transcends the different technology stacks that folks might know about, right? Whether I might know how to program in Java and you know how to program in Python, and some other folks might be implementing databases using JSON or relational databases. Some other folks might be implementing some XML. So regardless of what the technology is, UML allows us to have a common language so that all engineers can talk to each other, okay? And it's based on object-oriented fundamentals, inheritance, objects and attributes, and one-to-many relationships and whatnot, right? And the class is the ultimate item or diagram that allows us to capture multiple attributes that are common, that are describing a single concept. Right? We talked about using these boxes that have three different sections that have the name of the diagram of the class, then the attributes, and we said that we were going to ignore the methods down below, right? That we were going to focus only on these attributes and their data types. We talked about attribute, we talked about multiplicity, specifying how many of one thing is related to other things, right? How many are in the relationship. We also talked about enumeration and mentioned that we use stereotypes as a mechanism to implement enumerations. Stereotypes, we said that was an extension to the language. Language, not, all languages have their limitations of what can you represent with a language. So stereotypes allow you to create your own ideas of what this box means. Usually, if you don't have a stereotype, the default understanding of what this box means is that this is a class and that these are attributes. But you can override that meaning by creating your own stereotypes, right? And there are some standard stereotypes of what people have used stereotypes for. For instance, enumeration is a very common stereotype, okay, and that describes this and says, hey, this is not a class, it's a new data type okay, that establishes valid values of that data type. Okay, so these should not be interpreted as attributes or properties, right? These should be interpreted instead of the possible values that this data type can have. Now you have been using an enumeration for quite a while that is very common in programming. The integer, so the data type integer is an example of an enumeration, right? It's a very large enumeration. All the symbols, all the valid values for the enumeration go from minus infinity, including all the negative whole numbers, passing through zero, and then going into positive infinity. All the whole numbers between 0 and infinity, right? So that's a large enumeration. It has all the valid values listed here. Okay, those are not properties, right? Those are values. Okay, so again, stereotypes allow you to extend the language and provide your own explanation of what this box means to you, right? And enumeration is a very common and very useful stereotype. We also talked about specialization and generalization as a means of being able to break up certain ideas that can be implemented or described in terms of others, right? That perhaps one idea is only a special case of some more general idea, right? And the example that we used last week when we discussed this was a very common example is the using shapes, right? Where we might have multiple shapes. Maybe you have a rectangle, right? And that has some attributes such as has a name, has a color, right? Has a background color, BG color. It might have a width, right? It might have a height. Okay, and you might have another shape, right? Let's make this a little smaller. There you go. You might have another shape. Oops. What? Where'd it go? Okay, copy this, paste. You might have maybe a circle that might have also might have a name, a color, a background color, but it might have not a width and height, but instead it might have a radius, right? Also, not only width and height, but this might also have a position, right? X and Y, right? So they both have X and Y, name, color, radius. It might have X and Y. Okay, so it looks like there are some common attributes for both of them, right? And there are some. So these names, colors, background color, X, Y, there look to be some common attributes for both, but then you have things that are special about the rectangle and circle. So what generalization allows you to do is to implement a general version of these, right, where you might capture things that are common to all shapes, right? So you might call this shape. You might call this a shape, which declares everything that is common to all shapes, so that you can establish a relationship between these two and say that this is a special case. This is an inheritance relationship, a specialization and generalization. So this is a general description of all shapes, and this is a special case of a shape, so that I can inherit all these attributes from the shape, so I don't have to define it myself. Same thing with circle, right? We can say that circle is a special case of the more general shape, right? And so I can inherit all the common things about all shapes and only keep the things that are special to me, like the radius, right? So circle and rectangle are special cases of shape. Shape is a more general case of rectangle. There are also all sorts of jargon terminology for this. We say that this is a base class, right? And these are subclasses. We might say that this is a superclass, and these are all subclasses, right? We might say that this is a base class, and these are derived classes. So all sorts of names. We might say this is a parent class, and these are children. So they all mean to say the same thing, right? That there is there's a generalization and specialization relationship between these two. Okay. So yeah, so we will learn how to implement this in a relational database a little later. We also mentioned that certain attributes might be multi-valued, right? Like a string, like maybe an array of strings that have multiple values for that particular attribute. We also mentioned that if you have multiple classes, you have these types of relationships, right? The generalization, specialization, but you also have a general association where an author class might be associated to a book. And we capture that with a simple line between the two, right? We might optionally also give the next to the class, we might also give a role of what that class plays in that association, right? We might say that authors, they write. What do books do? Well, they're written by, right, the author, and you put the role next to the class. So the intent here is to learn how to read these class diagrams, how to create them, how to eventually, basically what we want to be able to do is design this as a class diagram, but then convert these into tables, right? Right, or Java classes, or C# classes, or some JSON document, right? These diagrams are only meaningful for documenting these things, but at some point we need to convert them into something concrete, right? Again, either in a programming language or in a relational database using a relational model, right? So we need to be able to read them, create them, manipulate them. Additionally, we said that we could add on each end of the association, we can add a multiplicity, right? That says, and that specifies how many of one instance participate in the association, right? For instance, many authors write many books. There are some very common multiplicities that are used, very, very often in, when you're reading these diagrams. In particular, we have the one-to-many. The one-to-many is a very, very common type of association where it establishes that one person, for instance, might be related to many phones. Okay, and the way we capture that is that we put a 1 next to the 1, and then a star or an asterisk next to the many side of the one-to-many relationship. Also very common is the many-to-many relationship, where many instances of one class might be related to many instances of another class, right? So many actors are related to many movies, right? But it can also be thought of as two one-to-manys, right? That one actor might be related to many movies, or that one movie can have many actors acting in that movie, right? So again, these two, the one-to-many and the many-to-many, are some of the more common types of relationship and associations that we'll be working throughout the semester. We also discuss the concept of reifying, that even though this many-to-many, this many-to-many is conceptually just fine from a UML standpoint, right? And it's fully documented. You don't need to do anything else. Oftentimes, we need to consider the technology that we are going to use to implement this, right? In our particular case, we are interested in implementing it mostly in a relational database, right? When we say we want to implement it in a relational database, we often say that we want to identify what the relational model is, right? This is a conceptual model, right? It's a diagram, it's paper, you're drawing things on paper, so it's very conceptual, very abstract, but you want to implement it into something more concrete, like in a relational database. And in the relational database, you can't implement this diagram, right? This many-to-many. And so here it is again, this diagram right here, many actors in many movies. So you need to convert it into an equivalent implementation that can actually, an equivalent representation that can actually be implemented in a relational model, right? So we're going to convert this one many-to-many relationship into two one-to-many relationship, where the one is on the one side, right, and the star is in this new class that we're creating, right? And this new class, it's often referred to as a mapping class, right? It's mapping what actor is acting in what movie, and what movie is whatever actor is acting in, right? It's mapping these two things, right? So the act, right, of converting this many-to-many into two one-to-manys is referred to as reify, to make it concrete, to convert something that was abstract into something that is more concrete and can be implemented. Now, if this mapping class has attributes here, right, has attributes, we want to be able to distinguish between classes that are being used exclusively for mapping, right, one instance mapping into another instances, right? We want to distinguish those mapping classes to classes that are not only mapping, but are also establishing and describing the relationship, right? So, for instance, association classes are maps between many to many, so star star, right? But not only are they mapping, but they are also explaining or describing the association, right? They're saying they're capturing some value, right, that enhances that association, right? That says, okay, well, this author is writing this book, right? Oh, and by the way, this is the edit log, right? As they're editing the book and writing the book, well, they're making all these entries. This is the paragraph that you wrote yesterday. This is the paragraph that you're currently writing today, right? So here's an example that contrasts these two ideas, the mapping class and the association class, right? So again, the mapping class is just saying, that which actors are in which movie, right? And there's a many-to-many. Both are many-to-many. Both are many-to-many. The difference is that here the casting is not capturing anything else other than a relationship between the actor and the movie, right? This actor is in that movie. That's it, right? Now, if you want to go a little further and say, oh, by the way, this actor, when they were acting in this movie, this is the role they were playing. Okay, now you've added this field, and you know what role you play, maybe what if you got an award for it, right? Whether you were nominated, right? Let's see something on the chat. Is there any content in casting class? Yeah, we'll talk about it in a minute, right? From UML's point of view, there isn't. There is nothing else other than that, right? From the implementation point of view, right? Whether you're implementing this in Java or you're implementing this in SQL, yes, there's other things in there, okay? But from UML's point of view, there isn't, right? And we'll talk about that in a minute. Does association update previous info or add info? Yeah, exactly. So what makes this an association class is that it's not only a mapping, but you also have other fields in there, okay? Now the primary keys and foreign keys, those don't count. Those don't count, right? Those are for implementing this right here. See this one-to-many right here? This one-to-many right here already captures the facts that there is a one-to-many. Now, if you're implementing this in a relational database, the only way to implement this one-to-many is to use a primary key, foreign key, right? So adding primary keys and foreign key to this diagram would be redundant, right? Because this already implements that, right? And if you were implementing this in Java, you would not be using foreign keys and primary keys. Instead, you would be using arrays. So UML is not concerned with the actual implementation, whether you're using a relational database or whether you're using Java or C#. It doesn't care, right? It leaves it up to the software engineer how they're going to implement this one-to-many, right? Again, if you're going to use relational databases, it's primary key, foreign key, okay? If they use Java, they're going to use arrays. But UML typically is not concerned with those implementation details. Now, depending on your audience, if you know you're going to be talking to Java developers, then you would use arrays on either end. If you know you're going to be talking to a whole bunch of database folks, then you know that you might want to add here foreign keys, primary keys, right? But if this is exclusively UML, then you do not you do not put anything in there. Otherwise, you would be committing to a specific implementation. And that's not what UML is all about, right? UML is about, keeping the conversation at a very high level, right? And leaving detailed implementation up to the developer and the engineers to figure that out. Okay. Let's talk about aggregation. So aggregation is a one-to-many relationship. It's a one-to-many relationship, very much like we saw earlier, right here. Here's a one-to-many, yes. But this one-to-many is leaving out a couple things, right? It's just saying that one person is associated to many phones. Okay, I might have a phone for work, another one for my personal phone number, and so on and so forth, right? But I'm not establishing here any other dependency. Okay, I'm leaving it up to the developer, right? What they want to do, how they want to implement this. Yes, but if I want to document further, for instance, that there should not be any life cycle dependency, okay, between the two classes, then I can add a diamond here, okay, on the one side. On the one side, I can add a diamond, right? Let me give you an example. Let's see. Imagine we had an order class and you have a product class, yes? And for instance, here's a couple orders, order 1, 2, 3, and order 2, 3, 4, okay? Now, the order 1, 2, 3 might have products A and B. So you're ordering, 2 of product A and 3 of product B, right? And there are 2 orders of product X, Y, and Z. Now, what happens if I remove, and then you have these records, right, in the database. You have a record for one order, and they are related to 2 products over here. What happens if you remove the order? Would it make sense to remove the products? Makes no sense, right? You would not remove the products, right? It's like somebody calls Chipotle and says, I want some tacos, I want some burritos, and I want some and this and whatnot, and it says, oh, cancel that order. Okay, well, the product is still on the shelves, and I haven't yet started, and if you cancel the order, well, the products are still there, right? So to establish and say that that there should not be a life dependency between the two, that if you remove one, it doesn't mean you remove the other records, okay? To establish that, you use this empty diamond, If instead you want to say that there is a life dependency, meaning that if you remove one, you also remove the other, you can use composition. Composition allows you to establish the fact that one is made up of the other, right? If you remove the one, the others go away as well. Let me give you an example. Here, for instance, you have email. Ooh, I guess I meant to say phone. Let me change that right away here. Let me put here phone. I meant to say phone here. Here, like that. And let me put this right above here, and let me put solid white. Anyway, I'll fix it later. Okay, so you have a person having many phones, right? And you might have, for instance, Alice, a record of Alice, and then Alice having many phones, right? So you have the phones in a different table, implemented as records, right? And then you have Bob having 3 phones, right? Again, a record for Bob, and then a record for phone somewhere else, okay? Now, would it make sense that if I remove the record Alice, would it make sense that I keep the phones even though I don't have a record for Alice? Would it make sense to keep the records for Alice? Probably not, right? It makes sense that if we remove Alice, we would also propagate that delete over to removing the other records, right? So there is a life dependency that if I remove one, I also remove the others, right? So to capture that, we use the filled-in diamond, right? That there is a life dependency. It's a composition. Make sense? All right. So here's back to the audience I was mentioning earlier, right? That depending on the audience, you might want to add to your UML diagrams and add a couple more documentation there based on who your target audience is. So for instance, consider this. simple diagram, which establishes the many-to-many implementation, right? Mapping between the actor and the movie. Now, as far as UML is concerned, you're done, right? You know, you're saying that this actor is in those multiple movies, yes? And now, if you're going to implement this in Java, right, you could implement this with arrays, right, where you have an array of actors, an array of movies, okay? And so even though that's an implementation detail, and if you know you're going to be talking to your audience is Java audience, you might want to add those attributes in there that are specific to that audience, the Java or C#, so diagram and Java or C# audience, right? They might make it, this would be much more understandable for them and says, yeah, I could totally see that of these arrays where one actor has an array of all the movies and the movie has an array of all the actors, yes? Or they might say, well, I need more information about the actor in the movie. Maybe I need to capture the role of the actor in the movie. I want to capture other pieces of information. So I might need an intermediate class in between, right? And I might implement it this other way, right? Where I might have a casting, like a mapping class in between that says which actor is in which movie, and we would have maybe a variable there of type casting and the movie casting pointing to this over here, okay? So this would be implementation specific. Now, typically you would not capture these attributes, right, in UML, right? Because again, UML is all about keeping the conversation as high as possible, right? But if it helps the conversation with your audience, then certainly go and add those attributes to make it more clearer for that particular audience. Same thing for the SQL folks, right? If it helps the conversation, certainly because you can't implement this in a relational database, you definitely need to at least add a mapping table in there, right, that says that this actor is in that movie, okay? And the diagram would be enough if you just have these two one-to-manys, right, and the many sides in the middle mapping table class over here, right? But again, this might be, as far as UML is concerned, this is enough to capture these two one-to-manys. But it might help the conversation when you're discussing this with, how to implement it and talking to the relational folks, right? Relational databases, it might help to explicitly add primary keys on the tables, and then the foreign keys that refer to each one of those primary keys in the other tables, right? But again, this is already somewhat misusing UML, right, to talk about implementation details. But again, UML is only as good as it can portray or explain and document on how is it that we're going to implement something. Let's see on the chat. Why we are not using association in this example, we are adding a field. I'm not sure. Does association update why are we not using association? I'm not sure what you mean. Maybe the one line over here between the two. Not sure what you're referring. You want to speak up, maybe?
In the second one, in the second example, we are adding the actor ID and the something else ID that I cannot see.
Is this the one you're mentioning?
Yeah. So in can you go to the next slide? I meant slide 30.
Right here?
So like in the initial example, it's fine. In the second example, we are adding active ID and movie ID as well. As we are adding, what do you call? We are adding fields. Shouldn't we just show it with association as well?
Association, you mean association like this?
Yeah.
Sure. Yes, I did want to talk about that. It's very common that if you're using older UML, association was not part of was not still part of UML 2.0. Association was introduced in UML 2.0. So you will find multiple cases where the association will be represented either this way, if folks are using still UML 1.1.0, or if they're using a more modern UML, they'll be using this notation instead. And I just wanted to point out that they're equivalent, but you might see it represented in either way, and they mean basically the same thing.
Is there a preference between them? Like, how can we know that we have to use the 1.0? Like, is there a place?
This is the more modern implementation. I would use this representation, but I will accept either one. This is still using a lot of people are still using this older representation. And I just wanted to introduce to you this association, because you might be reading UML diagrams that are a little more modern, and I wanted you to be able to read and understand that this is just basically a many-to-many, right? And it's a mapping table that has additional fields in there, and not only establishing mapping between two classes.
Thank you. Thanks a lot.
Sure. Let's see on the chat. Do aggregation and compilation go both ways if you remove? No, it only goes one way. It goes from, so in this case, right, if you remove the page, or if you remove the person, you remove the phones, but not the other way around. If you remove the phone, it removes the person. No, it only goes from the diamond to the other element, the other class. Excellent. Excellent questions. All right, excellent. So let's move on. Let me close that. And so let's see. Let's talk about we have enough information to discuss the assignment. So let's move on to the assignment and get you going there. Let's see something on the chat. Can you have 2 black diamonds? I've never seen 2 black diamonds. No. On the same line, no, I've never seen 2 black diamonds. That if you remove one, removes. Oh, interesting. No, I've never seen it. Right, so let's take a look at the second assignment. And let me open that up. Okay, so let's see. All right, so the first assignment, the intention was to get you going, and creating a database, creating a table, inserting, selecting, and whatnot. And this one is going to give us a chance to practice on designing databases, right? And we're only going to be covering just a few things that we just discussed. In particular, we're going to be discussing, creating a simple class, then implementing a one-to-many relationship, and then a many-to-many relationship. That's it. Okay, just to give you enough to complete it by next week. Right? In later assignments, we'll give you more things to design. Okay, but because we still have to take a look at inheritance, for instance. We need to take a look at aggregation and composition. So as we progress throughout the semester, we'll be adding more things for you to practice, design, and implementation. So for this week, we're only going to be focusing on implementing a simple class, implementing one-to-many and a many-to-many, right? Also, all the assignments are going to follow the pattern where we'll ask you to do something, right? And we'll fully walk you through every single step all the way. So we're going to handhold you doing it once, right? And then there's going to be a section that is called, now you try it, right? So where we're going to give you, say, okay, now that you've done this, using that as an example, now you do it, right? And we'll give you a couple parameters, a couple requirements, and then you go off and try it on your own. So you get a chance to practice it. And you see somebody do it, and then you do it yourself. Okay. All right. So UML, there's a couple of UML class diagrams. For this one, we're going to ask you to do is basically draw a UML diagram. Okay. We'll ask you, you'll add a whole bunch of diagrams, class diagrams. You'll connect them. Right, and at the end, I think you're going to end up with 5 class diagrams, 5 classes, 1 diagram, 5 classes in that diagram, and then a whole bunch of association between them. All right. Now there's a whole bunch of tools that you can use. One tool that I used a long time ago. I hadn't used it for a while, but I recently went back to it and I love it. Is Lucidchart, right? So if you go to Lucid.app. Lucid.app. I believe it's free for, I don't know how many diagrams that you can generate. And after so many diagrams, I've been, I had used it a long time ago. I filled it up. I never went back to it, and now I went back to it. Now I'm using a paid version, which gives me unlimited number of diagrams. I love it. Right? I think you will have enough diagrams free for this course. If you really can use it, Lucid.app is really good. So definitely let me add this as a link here. And so let's see, we'll put here Lucidchart. Lucidchart. There we go. All right, excellent. Oops, I just ruined my layout. Let me change this real quick so it doesn't look as ugly as it looks right now. File, page setup, and this is maybe 0.4. Let's see. That's still. Oh man, I ruined my 0.3. All right, there we go. Okay, so let's take a look at the assignment. So the assignment asks you to do the following. So we're going to be building a blogging application, right? Like a micro blogging application, maybe something like Twitter or Facebook or something, right? And so the first thing that we're going to do is that we're going to create a class that represents a blog, right? Now, in the previous assignment in last week, we created, I believe, a user class, right? With a first name, last name, so on and so forth, right? We're going to reuse that. We're going to bring that here. And so we're asking you, we first give you a first class. We say, okay, this is how you would build a representation of a blog class that has the following attributes: name, topic, where name is the name of the blog, and then the topic. And basically what we want to do is that presumably is we want to allow a user to be able to have any number of blogs, right? Maybe a blog about cars, another blog about space, another blog about neural networks or something, right? And me as the author, right, I can maintain multiple blogs, right? So there it is. So the first one is that you're going to create a blog. Again, using Lucidchart. Let me open up a new page here. And so you can use this right here. So let's drag this here, and this will be blog. And let me make this a little bigger. And so the attributes are going to be, I believe, name as a string. You're going to have topic also as a string. Now, topic would be a great opportunity to have like an enumeration, right? Where the topic might be like a drop down, and you can choose which topic or maybe you can add a new topic, right? So as opposed to just being a string. Also, we have a created, which is a date, and updated. Okay, and nothing here for the methods. Okay, all right. So there it is. So we're going to give you that, right? Then we're going to ask you to create your own class, right? So on your own, we're asking you to create a post class, right? So this will be a class that allows you to represent all the posts that folks are writing, right? And so posts are going to have you're going to have a title of the post and then the actual body of the content of the post, right? So we're going to ask you to drag here, create a brand new class, right? And call it post, right? And with whatever attributes we ask you to put in there, okay? All right, so that's the first part, really easy, right? So the next part, we're going to ask you to implement a one-to-many relationship. So first, we're going to create a one-to-many relationship, and then we're going to ask you to create a one-to-many relationship, right? So the first one-to-many relationship that we handhold you, right, that we walk you through is to implement a one-to-many relationship between user and a blog, right? So you're going to implement a user class, right? So which is the one you worked on last week, right? So this is user. That I believe it has things such as first name. Okay, let's make this a little bigger. had something like last name. I don't know if it had anything else. Maybe it might have username. I don't know if it had like password. Maybe, I don't remember. Okay, and notice that I'm adding created and updated to all my classes. Okay, and this is very useful for implementing databases that you want to be able to audit, right? That you want to see if when was the last time that a record was updated, or when was this record created. So it's very useful. Later on, we'll learn how to implement that in relational databases. Okay, so this is my user, and to create the one-to-many, that's easy. You just drag and create here an association. And we say that there's none here, and we're going to add multiplicity. So we're going to say that this is 1, and this is going to be many. Okay, there we go. Right, and then you can move this a little bit away, like that. Okay, excellent. And maybe make this same size. Perfect. And the post here the same size. All right. So then once you've done the one-to-many between user and blog. Let me see in the chat. Can we generalize created and updated to a parent class? Sure. yes. You could maybe do something like a you could say something like a class called auditable, like an auditable class, right? That has created and updated, right? And then these folks can be generalizations of this, right? So for instance, this could be inheritance, and this could be something like that. This is what you had in mind, right? And then do this from this. So this one's also like that. And this is a generalization, right? And having done that, you could remove these two from here. You can remove that, and you can remove these two from here. I didn't ask for it, but definitely would be a great idea, right? So go ahead and knock yourself out. And go do it. But it's not required, right? But you're welcome to do it. I think that's a great idea. Excellent. Good point. Something in the chat. Let's see. Can we generalize? Yeah. Okay. All right. So having shown you the example of creating a one-to-many between user and blog, we're going to ask you to do a one-to-many relationship between the blog and a post. So basically, the way the application would work is that one user can create many blogs, right? Again, a blog about cars, about spaceships, right? Another one about neural networks, and then they can choose which blog they want to work with, right? And then once they chose the blog, they can then maybe create a whole bunch of posts, within that blog. Right, so you can post a blog. So there's a one-to-many relationship between blog and post, and you can do that. You can work on that. Okay, so that's easy as well, right? And the next one is a many-to-many relationship, and the relationship that we're asking you to do is the first one we will create for you. The first one is a rating class. So the rating class is going to allow users to rate a particular post. So one user is going to be able to rate multiple posts, and one post is going to can be rated from multiple users, right? Now the implementation is this one right here, right? Basically, this is it's an association, right? And we have a many-to-many has been reified, and we have two one-to-manys where the ones are the two classes that are being related, and the asterisks are on the mapping class rating. Okay, I'm going to implement it just to illustrate. I'm going to implement it as an association class, right? And so I will take either one. You can either do it with an association class, or you can do it with a rating class like this. Okay, so let me show you. So you could totally do this and just copy and paste that in there. I'm going to just show you and I'm going to use it. I'm going to implement it using as a association class. I'm going to copy this, and I'm going to call this rating, and the rating. Wait a minute. I need my keyboard. I need to backlight it. There we go. Yeah. So rating is going to have whether I liked the blog, the post, right? And this might be a Boolean. I might give you a score, like from like a star, and this might be an integer. I might give you also a short comment on that particular post. Okay, and make this a little bigger, right? And this is also auditable, right? So maybe this inherits from way down here, auditable. Right, I'm going to make it big over here, and this is inheriting. Okay, let's move this a little bit slow. Okay, there we go. And let's make this a little smaller. Here. Okay. Okay. So this is a meta-domain relationship between these two, and the way we're going to do this is that we're going to create a meta-domain between these two, because we're going to use an association class as opposed to a mapping class. Right. So there's a none here, and the multiplicity is that this is a meta-domain. So meta-domain. Okay. Many and many here. And then here, we're going to create the association. I'm going to go here. I'm going to draw it here in the middle. It's going to be none, and this is going to be dotted. There we go. Okay, so now this is being implemented as an association class as opposed to using a mapping class. Right, and they're equally fine. Either one is fine. You're welcome to either go with what we gave you in the assignment and do it this way, or right, implement it using this way. All right, this is the more modern way of implementing it, but this is what you will see most commonly in a class diagram. All right, so having done that, we are asking you to now, having done the rating for you, now you try it. Right? We're asking you to create a reply class, which implements a many-to-many relationship, again, between the user and the post. So rating is just a thumbs up, thumbs down, right? Or a short score, right? Whether you liked it or not, from a range between 0 and 5, how much you liked it. Whereas a reply is going to allow me to engage in a conversation, right, where I create a reply. So one user can reply to many posts, and one post can be replied to many users. But in addition, a little later, not now, right, we're gonna add a self-reference. Not now. We'll do that in the next assignment. But I just wanted to let you know what the difference between a rating and a reply. Okay, so the reply will be that you'll add an additional class down here. Again, a many-to-many as well. And so let me copy that. All right, so this will be a reply class. Reply. Okay, and it'll have properties such as the reply itself. It's a string, right? And then a many-to-many between user and post. Okay, so I'll leave that up to you. You implement that. So at the end, you're going to end up with something like this, right? With 5 classes, at least 5 classes, 1, 2, 3, 4, and 5, unless you want to add this generalization in there. So print this as a PDF and then submit it as a deliverable. Okay? All right, any questions on the second assignment? All right, so let's move on then. Let's move on. So after the second assignment, let's move on to data design, right? Data design. So data design. So remember what we're trying to do, right? We're trying to come up with a technique that we draw all these diagrams, right? And once we draw these diagrams, what we want to be able to do is convert these diagrams into their equivalent relational model. Meaning tables, right? When we say relational model, basically we mean tables, okay? Or we might use jargon such as relational schema, right? And by what we mean by schema is the structure of what the table going to have, right? All the columns, all their data types, right? So basic relational models, I want tables, and relational schema is, well, what those tables look like, right? What are the fields, what are the columns, and the data types, yes? And so that's where we're going, right? We want to be able to convert these types of diagrams. We're going to convert these types of diagrams into their equivalent tables, okay? So that's our ultimate goal. So here's, for instance, so one might say, well, why don't we just work with tables? Why bother the diagrams, right? And so what I'd like you to be able to realize, right, is that it's much easier to work with these diagrams than to work with tables, right? Tables is source, right? Working with source, and if we have a graphical diagram representation, it's so much easier to work with a picture than to work with source code, right? Especially if you can, automatically convert between the two. Okay, it's much easier to have a graphical representation and then convert it into source code, or vice versa. So we want to know how is it that we can go between the two worlds. How do we go from diagram to tables, and then from tables back to diagrams, right? And we like to be able to almost treat them as one and the same. Okay, obviously always knowing what the limitations of that is, right? That you can't just go from a diagram to a table. You need to reify a couple things, right? You need to, what are the limitations? What are the caveats? Okay, so for instance, imagine, I'm trying to design a simple database to keep track of my CDs, right? And I don't know, maybe I'm aging myself. I don't know if anybody might in the audience still uses CDs. I doubt that folks are still using CDs. So I might need to re-update some of these slides using some more modern technology. Anybody using still CDs? I'm wondering. So anyway, CDs were are a I use VHS. Okay, well, I use Betamax. Right. So yeah. So imagine I want to I have all these CDs with lots of music from way back when, and I want to create a database to capture all this information. Please fax this lecture. Yeah. So I have all these CDs, and I want to capture all these CDs, and so I create a table where I can enter the title for the CDs and the when it was released, and the band and the genre, whether it's rock and roll or salsa or merengue, and so I also want to capture what are the different songs in each CD, and for that I create a different table I call it track, right? And in there I want to keep track of I want to capture which track it is, the first track, the second track, and whatnot, the name of the song, and how long is that song, right? And so I also want to keep track. I want to capture the fact that certain tracks belong to certain CDs. Basically, I want to establish a one-to-many relationship, right? That one CD has a whole bunch of tracks, and the way you do that in a relational database is that you have two fields. One field in the one side, right, that uniquely identifies the record, and then you have on the other, you have a field that can have a reference to the other field, right? And that's how you establish, right? You can have a whole bunch of songs that maybe 10 or 20 songs that say, hey, I belong to that CD there, right? So it's a reference. Let's see a question in the chat. Could I get the lecture notes via Telegram? Sorry, I don't own a Telegram, but I can send you my notes via carrier pigeon. All right. Let's see. So yeah, so in a relational database, right, in the relational model, right, this is the relational model. We're establishing these tables, and so some fields are referencing some other fields in another table, right? That's why we call relational databases, right? Because some fields relate to other fields, okay? And that's how you structure the data. And we call these unique identifiers, we call them primary keys, and we call these fields here that are referencing the primary keys, we call them foreign keys, right? And they have the primary keys have the peculiarity that they are unique, right? They uniquely identify a record, right? Just like your student ID or your social security, right? Those are examples of primary keys, okay? Even a phone number is a primary key, okay? Credit card, that's a primary key. It uniquely identifies you as a customer at a particular. So in this example, the CD ID and track is a foreign key. So this, yes, exactly, right? So this CID in the track is a foreign key that is referencing a primary key in the CD table, okay? And these are tables. These are not classes. These are not tables. I'm sorry, these are tables, not classes, okay? But we can certainly imagine how we can represent these are classes, right? And the point I'm trying to make is that it's very hard to design a database by working with tables, right? That it's much better if you work with classes. You do all your design in the classes, and then you have a mechanism that can easily translate those UML diagrams into these tables, and vice versa, right? If you're looking at this design, this implementation of these tables, if I want to make a modification, right, it's harder, right, to visualize in code like this. It'll be much easier to convert this back into a diagram, make my changes, and then convert it back into the relational model. Chat, can you have multiple different types of primary keys? Can you have multiple different types? You can have multiple primary keys. Yes, you can have multiple primary keys, and you can combine them into what are called compound keys. So like a compound primary keys, and yes, you can have them be a combination of the two, by like one an integer and one a varchar. Other than naming convention, how do you know if a key is a primary or foreign key? Yeah, when we get to actually creating these, right, you will specify, this is a primary key and this is a foreign key. I believe I have an example way at the bottom of some tables. So for instance, here's an ID, and you deliberately, you literally say that field ID is a primary key, and these two fields, company ID here and this employee ID, they are foreign keys that are referencing some other field, right? And this employee ID is referencing some employee over there, right? So we'll get back to that. It's towards the end, right? Let's get back to this. So yeah, right now we are using this notation of underscores and bold letters and italic. Okay, so for instance, italic here means that it's a foreign key, right? And it's referencing some. So I guess this is not italic. This is not italic. And this is, if it's bold and underlined, it means that it's a primary key. Okay, and this CID, because it has the same name, then presumably it's referencing. Okay. All right. Excellent. So I'm very proud of my design, and I start going through my database, and I start filling out my database. And as I go through this and I get to my 15th CD, I realize that my database is not quite perfect. Okay. For instance, I noticed that I find a CD that has multiple genres, where the first half of my CDs, my first 10 songs are rock and roll, and my other last 5 CDs, I have now a new girlfriend, Latin girlfriend, and she likes salsa. And now I have like a mixture of rock and roll and salsa at the end, and merengue. And now that doesn't fit nicely in my database. Okay, so this genre, turns out that a CD might have more than one genre. Okay, or I realized that in a CD that I made myself, it turns out that it's an all-star rock and roll CD, and the first 5 songs are from Led Zeppelin, the next one are from AC/DC, and some other ones are from the Rolling Stones, right? And it says, oh, now my CD, the band, now you can have multiple bands, right? It's not enough to just have a band there. So even with this really trivial example, we see that the coming up with what tables I'm going to use, what fields, and which one-to-manys and many-to-manys they're going to have. Even with this trivial example, it could get pretty complicated. Designing this database, right? And the point we're going to make here is that the best way is to start at the diagram level as opposed to starting at the tables. Don't start at the table, start at a diagram. Okay, so UML class diagram is the best way to get started. Convert it into tables, but if you need to do any modifications, then represent it again as UML class diagrams, make the changes, and then convert it back into tables, right? So diagrams are your best friends, right? So here's an example of a class diagram that we're going to be using throughout the semester that represents a university, right? University might have things such as students, right? Departments, courses, sections, enrollments, right? And several associations or relationships, right? A department can have many students. A department can have many courses, right? A course might have many sections, like you're here, right? You're in section 4, I believe, and other students are in section 3, right? So there might be multiple sections, and you might be enrolled in many sections. So you might be in many sections all at once, right? You might be in a section here in databases. You might be in a section in in OO&D, and you might be in many other sections, right? So you are enrolled in many. So you have a many relationship between you and multiple sections, right? And we want to keep track of when you complete that course, that section, we want to keep track of the fact that you got a particular grade in that section, right? So the enrollment class can be used for that, right? It's a many-to-many that keeps track of the grade you got in that particular section, right? So notice it's the only meta-to-many. Notice it has been reified and has a star next to that class, and then you have a ones on the one side, right? Notice that department is not a meta-to-many, right? It has ones on each side, right? And it has a one-to-many with students and one-to-many with courses. And courses is not a many-to-many either, right? It has a one-to-many with sections. Okay, so we're going to use this example all throughout our semester. Let's see. Relationship with cardinality, we already covered that in the previous slide, so never mind this. One-to-many relationships, we see that the student has a department has a one-to-many relationship with student. One thing that we did not cover in our previous set of slides was the one-to-one. So one-to-one captures the fact that there might be one instance of a student, for instance, that might be related to a single instance of a permit, right? Where one student cannot have more than one permit, okay? And in that permit, you might capture things such as, a permit to park, for instance, at the university, right? And the permit might capture things such as your license, the car model, the car make, the color of the car, things like that, right? Now, somebody might argue, says, well, if all these fields here are being captured for that one student, and that student can only have one value for those fields, then why bother even having a separate class? Why can't just we move these fields and just move them into the student? Okay, that certainly would simplify things and would be one less class to deal with, right? But usually what we want to do is that whenever we come up with a class, we want to capture the whole essence and be as specific as what that idea means, right? So a student, right? Even we like to be able to think that our definition of student is universal. Okay, that it's not even specific to our use here as in the university. So for instance, a student in kindergarten certainly wouldn't be old enough to drive or to park, right? So permits is not really a fundamental description of what a student is, right? So even though the fields are only for that one student, we decide to put it aside, right, in a separate class all unto itself, and then say that there's a one-to-one relationship. Now, this one-to-one relationship says, right, that if you're a student, you have a permit. This says that if you have a record for student, you definitely have a record for a permit, right? Well, what if I don't drive? Or what if I commute through a rail system or subway or whatnot, or somebody drives me and I don't need to park at the university, right? So to capture that, I might have a permit or might not have a permit, then we instead use a 0.1, right? And this what says that the permit is actually optional. There might be a record with a permit for that student, or there might not be a record, right? So that's what this captures, optional, okay? Many-to-many, we also covered it in the previous set of slides, right? That says that one student might be related to many departments, and a department might be related to many students. That's if the the university allows you to maybe have like a major in computer science and a minor in art, okay? Although the example that we had earlier was that one department only had it was one department, many students, not many-to-many. But here it's allowing us to have like a many-to-many, right? And this is the way you would capture star on each side. We also are going to use a jargon that is common in databases, and it's the strength of relationship, the strength of relationship, right? We say that a relationship is strong, right, if the annotation, if the cardinality, right, is a known quantity, right? We know maybe that there's 1 or 2 or 3 that are participating in the cardinality, right? And we say that a relationship is weak, the annotation is weak, if instead if we don't know exactly the quantity that are participating in that relationship, like for instance, star, right? Or 0 to 1, right? It might be there, it might not be there, I don't know, right? So we say that it's a weak relationship, right? So if you have two classes where you have like a one to many, like a 1 and a star, we say that it's a strong to weak relationship, or vice versa, a weak to strong relationship, okay? So again, that's just jargon. Many-to-many is a week to week, right? Because you have star and star, right? So that's week to week. Or if you have a star and a 0.1, that's also week to week, right? But if you have a 2 and a 4, then that's a strong to a strong relationship, right? Which is where we that's the jargon that you would use. Okay, here's just a couple more examples, right? Strong, strong, weak, weak, strong, weak, and weak, strong. All right, any questions so far? All right, let's keep going. And so yeah, so one of the something on the chat. Let's see. Is 0. So 0 is strong because you know exactly 0 are participating. If it's 0, then probably you don't even need the class, right? And if you're saying that it's 0, you're saying that there is no association. There will never be a record, right? So might as well not even have the class. So it's very seldom that you would have 0. Yeah, so the benefit of having a class diagram is that it's visually, can be interpreted visually, right? That like they say, right? One picture is worth 1,000 words, right? Or you could say one picture is worth 1,000 lines of code, right? That only just by looking at a class diagram, you can, if you're looking at this class diagram, you can immediately would be able to answer certain questions, right? For instance, just by looking at this, you could probably say that you can easily see which students are enrolled in which sections for what course, right? Because you can navigate right from the student, you can navigate to the enrollment, to the section in the course. You can know, you can answer that question, right? Or you can determine which courses are taken by which students, or which professor is teaching which students which year, right? Or the size of the section for a particular course, right? So just by looking at the diagram, you know that these kinds of information is being stored in that database, right? You can also determine that certain things cannot be answered by the class diagram, right? You can, for instance, if a particular student is enrolled in a department, right, and you're in the art department, and then they change over to the computer science department, well, that kind of information is not being captured here. I don't have like a history of you. I can only see the current department that you're in, but I can't see like a history of the departments that you've been in, right? So certainly that is not in the class diagram. Also, I can see that a particular professor is teaching a section, but there's no relationship between a professor and a student that I can say that a particular professor is advising a student, right? So again, those kinds of things are not being captured here at all. So, and we can do that just by visually looking at the diagram, right? So yeah, so there's definitely a great utility of using class diagrams. All right, so also if we go further, remember where we're going, right? We're going that our intent is to take a class diagram and convert it into a table, and vice versa. From a table convert it into a class diagrams, because in the design process, whenever we want to modify something or create something, it's best if we have it in a diagram form, right? So let's start looking at what is the relationship between a class diagram and the tables that we want to create. Okay, so first of all, we're going to start looking at the cardinalities here, right? These cardinalities are going to be very, very useful at identifying what are the equivalent tables, right? How we're going to implement this. Okay. So let's focus on these cardinalities: one to many here, one to many. Okay. And let's try to visualize now what the tables might look like, right? The equivalent tables, right? So for instance, here's an equivalent table. These are equivalent tables that would implement this class diagram, right? So for instance, in the student class, you would have maybe a student table, right? That would have two fields. You would have the student name, right, with Alice, Bob, Chuck, right? The student name here. Maybe even the graduation year. I didn't put it there because of space constraints. But you would also have another field that is not listed here, right? That is not listed here. It's not listed because it's not relevant in a UML diagram, right? It's not relevant in object-oriented technology, right? But it is relevant in a relational database, right? There's a field called student IDs, or in a unique identifier, a primary key, right? That uniquely gives values to each one of the records. So 1, 2, 3, 3, 4, 5, 4, 5, 6, that uniquely identifies each one of the rows, okay? And notice that each table has this peculiarity, right? They all have primary keys that uniquely identify the records. All right, everybody okay with that? Right, but we don't have the equivalent here in the class diagram. We could have added it, right? Only for clarity, as we saw earlier, depending who your audience is, who you're talking to. So the ID column we made from the first assignment was a primary key. Yes, absolutely. Yep. And if you remember in that assignment, when you were creating that ID field, and you were selecting the checkboxes of what you wanted, I believe I had you check on the PK, right? And that PK means primary key. That ID was a primary key, right, for the user, right? I also had you check on, I believe, on the AI, which was auto increment, and I believe on the NN, which was not null, right? So that was saying that this is a primary key. It cannot be null, meaning it has to have a value, and the value was being automatically generated by the database, AI, okay? That was for the first assignment. Okay, and I had you use ID, right? And please always use ID. It'll just make it easier for us for grading purposes, but really you can name it whatever you want, right? So here's SID, EID, SCID, CID, and DID, right? So these are all primary keys. Excellent. Now, the way we implement the one-to-many here between the departments and the students, actually, no, I'm sorry, let me do the department and the course. I didn't implement this one-to-many between department and student. Let me look at the implementation of this one-to-many between course and department right here, okay? The way it's implemented is that the department has primary key, there it is, unique identifier, perfect, 10 and 20 for these different departments, perfect. So the way we're going to say that these courses, the web course, the software engineering course, and the database course, right? That they all belong to the computer science department, is that we're going to add another field here in blue, right? That is going to represent a foreign key, right? This is going to say that I'm going to refer to the department ID. There it is. It doesn't have to have the same name. It doesn't have to have the same name, but it definitely helps, right? It definitely helps to have them the same so that you can get it straight in your head, right? That this is referencing over there. So, and these values are taken from these values over here, right? And these values can not be anything other than values from here. I can't, for instance, put a 30 here. The database would stop me. It says, oh, there is no department 30, okay? And we'll talk about that a little later. That's called referential integrity. Makes sense, it enforces the fact that you can't reference something that doesn't exist, okay? So 10 definitely exists, and I can definitely add another one here. Maybe the course is law. What course in law might be debate, right? How do you debate in law? So and then this is referencing this other field here, right? And with a different color, maybe a little darker. This 20 over here, and the text is white. All right, I'll leave it there. And the course number, I don't know the course number for courses in the law department. Anyway, so that's how we say that this course belongs to that department 20. Everybody okay? All right. All right, so let's do that again. Let's look at another example. Here are the unique courses, course IDs, and we have sections, and we want to establish a one-to-many relationship between course and the section. Okay, and so we're saying that these sections, right, belong to these courses. So, for instance, here are two sections for course 5610. See that? So that means that these are two different sections for the web dev, and these are two different sections for the 4500 course, software engineering. See that? Right? And that's how we say that one course has many sections, and one course over here has many sections over there. These are referencing what parent record they belong to. Make sense? Now, okay, so we have these. We took a look at these two one-to-manys. This enrollment is not really, I mean, even though we have two one-to-manys over here, really enrollment is implementing a many-to-many, right? And it has been reified, right? It has been converted into a table here that is mapping students are being mapped to sections, right? Notice that the students have these unique identifiers and the sections have this unique identifier in red. See that? And what this says is that it has two foreign keys, right? It's referring to students here in this field, it's referring to these over here, and it's referring to these sections over here. See that? So for instance, what this is saying is that student 123, meaning Alice, is enrolled in section 321. There it is. It's enrolled in 321, meaning it's there. She's enrolled in web dev. But Alice, again, right, 123, is also enrolled in 567, meaning she's enrolled in also in 4500 in software engineering. See that? Right? And then we have Bob here. Bob is also in software engineering, and Chuck is also in software engineering. Right? And this is the final grade they get at the end of the semester. Make sense? Okay. So this is actual data perhaps stored in these tables, and we just want to what we want to learn how to do is to be able to think in classes, think in the class diagram, right? But be able to translate and implement their equivalent tables, and vice versa. Be here in the tables and be able to think at a high level in terms of classes. All right, that's the practice that we need to learn how to do on the fly. Okay, so here's a little more exclusive example, more explicit example. We have this foreign key of SSID referencing the primary key of the students, right? And here's these three foreign keys, right? Values referencing the primary key of the section. Right, same. The section has foreign keys 516, 5610, referencing the primary key of the course, and finally the department, right, referencing the particular department. Yes? Okay. So definitely primary keys and foreign keys are very, very important, right, when you're talking about a relational model, but they are irrelevant and even redundant when you're talking about a UML class diagram. And you have to be able to think in both places at the same time, right, and say, okay, what am I talking about, UML diagram, or am I talking about tables, right? And sometimes we can, make them one and the same, right? And sometimes it's useful to add the table fields in the class diagram only for documentation and for making it, more palatable for when we're talking to relational folks. All right, so we want to be able to convert between tables and classes, right? So, and vice versa. So let's start off with tables, and let's see if we can convert it into an equivalent class, right? So it's fairly easy. We already saw that classes more or less map to tables, and more or less the attributes in classes map to the fields or the columns, or the columns in a table, right? And the relationships, those lines, the lines that we draw between the class diagrams with the cardinality, that maps to foreign keys and primary keys, right, on the tables. Yes. So we would like to be able to come up with a diagram with an algorithm that we can throw at it a table and it spits out a class diagram, or vice versa. We give it a class diagram and it spits out a table, right? And then we want to become so proficient that we can do this in our heads, okay? So let's look at an example here. Let's go back to our previous example of the CDs and the tracks, yes? Now, to make it a little more interesting, let's add an additional table, right? The lyrics table, right? So the lyrics table is going to establish a one-to-one relationship with the tracks, okay? And basically what we want to be able to implement and say, we want to be able to say is that if you have a song, that song can only ever have one lyric, right? One, do you say lyric or lyrics? Lyrics, I guess. One song has one lyrics, yes? And that's the only lyrics that that song ever has, right? And so how do you enforce that? How do you implement that in a relational model, in the relational data, in a table, right? The way we implement that is that what we do is that we make a field, right? We make it both. We make it a foreign key and we make it a primary key, right? So for instance, this lyric, if we have a record, here's an example, right? Here we have a track, for a particular song. Here we now have another track, here we have another track, and so on and so forth, right? We have all these songs, right? And what we want to do is that each song only ever has a one lyrics, right? So if this is the song, well, that is the lyric, and that's it. This can only reference, if this track ID is 321, when this lyrics can only be 321. It can't be 432 or it can't be 543, right? It can only be 321, okay? And there can't be two 321s, okay? Because you can't have two lyrics for the same song, right? That makes no sense, right? So what we do is that we're going to enforce the fact that these are unique, right? By saying that this is a primary key, and primary keys are unique, right? But also we're going to make them foreign keys, meaning that these are going to be referencing these values in some other table. Make sense? So the way you implement one-to-one is by making a primary key also a foreign key. And that's exactly what we're doing here. In the lyrics, this is not only bold and underlined, but it's also italic, right? And so later on, we'll see how you actually implement it with primary keys and foreign keys, but when we get to SQL next week. But that's what we're doing, right? So we're declaring that to be a single one-to-one relationship between tracks and lyrics. All right, so let's see. Let's start looking at how is it that we would implement this, right? So we have the CDs as a class. This is the class diagram we would want. Starting with this right? This is the relational model. This is the relational. So let's say consider the CD database earlier. The relational model. Okay, the relational model is this is the relational model, and we want to spit out this class diagram, right? You have the CD class diagram, the track, and the lyrics. And notice that we left out the foreign keys and the primary keys. See that? And because the way you document that in UML is with the ones and the stars and the lines, right? That is how you document it. It would be redundant to also put here the CD ID and put here the foreign key CD ID in the track. It would be redundant, although it might be useful depending on the audience that doesn't understand what the association and what these things mean. In the chat, some track might not have lyrics, authors. A song without lyrics, I guess if it's instrumental, yeah, sure. Like some students won't have a permanent. Yes, and notice that we have a 0-1 here. No, see that? 0-1 means that you might not have a lyric, right? You might not have lyrics, meaning you might not have a record that contains lyrics that references the track. Yep, exactly. So that's why we have optional over here. Right, so if we have 1, there's only 1, but we could have 0. Right, so it's optional. Okay, so here's our algorithm. This is the algorithm that we are going to be using. Okay, question in the chat. I was referring to the Abigail's question. Okay, yeah. So here's an algorithm that we could use, right? So very simply, for every table that we have, basically we're going to create a class. That's easy. Okay. The next one, if you have 2 tables, right, and you have one table has a foreign key that references a primary key on another table, right? That means that the table that you're referring to, that table is going to be on the one side, right? Is going to be on the strong side. Okay, like for instance, over here, right? Like we did here. If you have here a foreign key that is referring to a primary key, well, that means that CD is going to be on the one side. There it is. CD is going to be on the one side. Now, we don't know about the second one over here. This one over here, I don't know. Same thing here. Lyric has a foreign key, right, that references a track. The track is on the one side. Yes? We have that. Well, what happens to the other table? What happens to the other table? Well, it depends. If that foreign key is also a primary key, right? If it's also a primary key, then it's a 0-1, right? 0.1, meaning it's an optional, right? It's a one-to-one relationship. If it's not also a primary key, otherwise, right, then it's just many, like we did on the track. Like the foreign key on the track that references a CD is only a foreign key. It's not a primary key. Okay, so that's, you have the star on that side of the table, right? And the attributes, we just copy over all the attributes except the keys and the foreign keys, right? All the artificial keys we do not copy over into the class diagram. Okay. Do you mean the foreign key is also a primary key of the same class? Yes. Yep. Like over here, right? See, the lyrics has a foreign key that is also a primary key, right? That it's referencing the track, right? So because it has that, then on this side, this is not a star. Instead of is a 0.1. Okay. All right. So this algorithm can successfully convert, for instance, this set of tables, right? You can convert these tables to an equivalent diagram. This is the equivalent diagram. Let's see if that's true. All right, so first of all, we're going to convert all the tables are going to convert into classes. There they are. So we have 5 tables. We have 5 classes. Perfect. Next, we have the student has a foreign key to the department. That means that on the department, there's going to be a 1. Okay, there it is. There's a 1 on the department. Now that foreign key to the department is not a primary key. It's a foreign key, but it's not a primary key. Here's my primary key. Okay, so since this is not a foreign key, then on the student is going to be a star. There it is, a star. Okay, between the two. If we continue, let's see, course, same thing. The course has a foreign key to the department, but it's so that means on the department is going to be a one side. It's going to be a one. There it is. And the department here is not also a primary key because this is my primary key. That means that under the course, you're going to be a star. There we go. See that? All right. So if you apply the algorithm enough times, you end up with this class diagram, which was perfect. That's the class diagram we had started off at the beginning. Okay. And right. And definitely, this class is worth 1,000 words, right? It's visually, it's easier to work with. So if you want to work with tables, it's so much easier. If you're going to design tables, it's better to convert it into a class diagram and do all your work on the class diagram and then convert it back into tables. And we haven't covered that yet, right? How to convert class diagrams back to a table, right? And that's what we're going to do in the next, our next lecture. Okay. All right, folks, that's all I have for you today. So please read ahead. Take a look at the remainder of these slides. And also, please look at all the slides for this week that are coming up so that we can move along in a faster pace. All right. Or if you have any questions, please bring them next time around. All right, awesome. Thank you, everyone.
Thank you.
Thank you. Have a nice night.
You too. Take care.
Thank you.
Good night.
Thank you. Good night.
Bye-bye. Good night.
I just have a few questions, Professor.
What's up?
So let me check. So how do you annotate if you require a specific number of entities to require? Like you require either 2 or 4 things to require. Like a student can only have 1, 2, or 3 associations with the department, but they can't have 0 or 4.
Yeah, so you can't do that in UML, but in SQL you can provide a pattern, like a and there you can specify what are the valid values, or you could make an enumeration, right? You can have an enumeration that a particular value has a particular can be only taken from a particular set, or you can also count. Right, you can say, well, you can count how many, and then not allow the count to be bigger than that, right? So you can use programmatic ways of doing that. In SQL, we're going to do we're going to use stored procedures, and stored procedures can calculate, right? They can say they can count how many records there are, and then not allow an odd number or an even number of values. So you can, but not in
UML. Okay, and then you reified the many-to-many relationship with the enroll. How would you do that with the association, like the modern method? You
say again?
You said that to reify many-to-many, you can use an association or something?
Yeah.
It's like the more modern method. Could we do that for that table, the student to enroll to section?
Oh yeah, of course, definitely. Yeah, this one is using the older annotation, right? The modern way of implementing this would be there would be a line between these
student
start to many to many here, and then a dotted line going to the enrollment. Yep.
Oh, your screen isn't shared, but I can imagine it. Yeah, I can imagine it though. It's just a direct line between the two, and then a dotted line between enroll and that.
Yeah. Can you see now?
Mm-hmm.
Yeah, you would have a line. A solid line between student and section, star and star, and then a dotted line to enrollment.
Is there a preferred method, I guess, for classwork or just for future work and like proofing, I guess?
No, I mean, this notation is still widely used out there. I just wanted you to be familiar with the newer notation. If you see it and you scratch your head and says, what is that? Right? It's just know that it's just a more modern notation of saying that this is a many-to-many. And that it has the mapping class has additional fields that is describing what the relationship is. Yeah.
Okay, and then just one more question.
Yeah.
It was on applying the algorithm. It's actually the slide right before the one you're currently on. so like SID is the primary for student. You said major ID in that case is a foreign key because
Yes.
it's referencing another key in that, right?
Yeah, this is a foreign key.
Yeah, and then what is that reference? Is that reference? It's just another name for DID.
Yeah, so you can name them whatever you want,
Mhm.
and to make it explicit here, we might use the same name like over here as well, DID, and then it's clear that it's referencing this over here.
Yeah.
But in reality, when you implement it in SQL, you can name them whatever you want.
Okay. And I'm guessing you can specify in comments or something if it's not
Yes.
clear. Okay, and then
Yeah, go ahead.
yeah, and then if you like, if student contains if student contained department name, which isn't the primary key in department, would you need to like specify that or something, or would that just not be necessary?
I'm sorry. Say again. If what?
If a student contained department name in it for whatever reason, it wouldn't be a foreign key because
Right.
department, yeah.
Right. Yeah. No. Each field can have. So within a table, you can have fields that have the same name as other fields in other tables. Right. They
Okay.
don't.
Sure.
Tables.
Okay. And you.
But you do bring back a good point. Is that later on when we go a little further, department names are already unique, and we might decide not to use the department ID over here because it's kind of like an artificial unique identifier. Your department name is already unique enough, so we might drop this and keep this instead. And then, and this would be our primary key now. And so all these would then be department names, right?
Okay.
Referencing the department that they belong to. Yes.
Okay. Sounds good.
All right.
Thank you.
All right. Take care.